Alright, here's some optimizing results. To optimize result, I applied what I propose here is a naive Bayes classifier. We assume that the appearance or existence of each word is independent, which would not be true in real life. But for instance, um, an adjective is more likely to be shown before a noun, but that's natural language processing knowledge and needs some semantic network ideas. For simplicity, we just applied naive Bayes classifier, which does the word just well. And what it does here is it applies maximum a posterior estimation, also known as the MAP rule. So the posterior probability can be calculated by the prior times the likelihood over the evidence here, and it can be derived to the following two equations here. And when these decisions will be made if this P is over 90 or 95%, which means this is pretty sure that um, this belongs to a certain category. Another thing here is the feedback goes to the ray train process. What this means is that we get the feedback from the end users, and these feedback are usually the structured data, and we can use that instead to retrain our system so that we can give better performance to individual. Like this, we see at the beginning of the presentation. Now, the customization part is the last step before deliver articles to end users. So, um, this step can actually make the topics more attractive associate with the last one. So what we do here is we want to filter news and tailor them based on individuals' taste accordingly. And this can be solved effectively by the mechanism of creating a hash table. So the hash table is associated with individual end users. If the user gives a thumbs up, we know that this is the topic that the user actually enjoy. And maybe for the next time, we will increase the order and present them um, prior to some other topics. If the author unfortunately gives a downside um, critic about the articles, then we will let the system know that this is the unwanted data, and perhaps the next time we will filter out that particular kind of articles and deliver it to the users to make them satisfied. Again, here you want the retrain process to the previous step. So the evaluation stage, I compare the k-means with the kernel method. What the k-mean does is just put a line here, and so that because of its linear um, clustering method, so all it can do is to cut it in half instead of since even though we know that this should belongs to like this curve and this curve, but the Kings cannot detect it. Well, the kernel PCA, as you can see, the results are pretty good. So it does what it does. Gives the best performance compared to the Kings. This is another example here, and uh, one thing to notice is that the because the because the uh, kernel-based PCA map the data to the higher hyperplane, but in the hyperplane, things can be divided by the linear clustering. But when it maps back, mm, it still got curves. But um, the curves can fit the clustering very well. As you can see here, the results are really promising. Now I'm gonna list some of the code. So this is um, first the pre-processing stage where we calculate the inner product here and determine the category so that the text, the corpora that we get initially from the internet will be ready to get a further processing for the next stage. What the next stage does is we take the kernel method of the principal component analysis here. So we put the data onto the hyper plane to do the training, and here is we send the training sample to the hyperspace H. Um, to calculate to solve the following eigenvalue and eigenvector. So when we get the eigenvector, we map back to the original space so that uh, the clustering range will be a nonlinear line. So I'm gonna run um, to some of the some of the examples that I illustrate in the presentation. So here is the k-means, and here we can clearly see that another disadvantage of applying the k-means, which is it needs to specify the number of the cluster that we want to cluster. So for the comparison, if we apply the kernel method here, then the clustering will be a curved line instead of the we cut half of the figure. All right. To better illustrate another two examples here. So again, this is the example I just shown, similar to the presentation, and we can define the range and get the eigenvector, the mean, and the boundary, and this boundary line. All right. So this is the last part, conclusion. To recap, the proposed idea offers an news topic pushing architecture. The total number of users are four. We know that it has some advantage here. Applicable, applicable to a large-scale network, suitable for topic recommendation, and it also suffers some problems that might be undermine the performance in a large scale unstructured data. Also, another problem is um, the huge amount of database that we need to create to remember to store the user's preference. But one thing to notice here is that the total number of users are far fewer than the total number of news information. right? So compared to millions of news topics emerging every day, it's actually efficient to store the preference by users' entry accordingly, rather than the other way. In practice, in order to apply the proposed scheme, more sophisticated mechanism needs to be applied and addressed, such as the relief, which is a practical approach to feature selection, and the local feature extraction, which is an extension of the relief, also the Apache Mahout, and the knowledge-based Weka. Oh, before I finish this presentation, I'd like to say a few words. Over the past few months, I have picked up quite a few techniques, and now I am able to apply some of them in my project, which is an excellent start for machine learning. I gotta admit that text mining field is a beautiful yet challenging journey, full of surprise and unknown factors. But one thing we know for sure is that this will have a very bright future and very promising future. And I think that concludes my presentation. Thank you for your time.